We will run out of water. They're running out of
The United Nations is warning today of an approaching global water crisis.
If you could find a cheap and efficient desalination method, you will be the richest man alive. The moment my apes teacher made that claim, I couldn't help thinking, yeah, why not? I want to do that. Well, since then my mind has steered elsewhere, but I remain intrigued. What is water desalination? How does it work? And how can we be more efficient? So hold out on the existential crises and World War water preparations, and let's look for answers. A typical desalination plant would use reverse osmosis and a combination of either thermal or membrane technologies to separate solutes like salt from sea and brackish water. In biological systems, various small and miscible substances can passively diffuse through a cell's semi-permeable lipid bilayer membrane in the direction of various electrochemical gradients or high to low concentration. However, larger or charged molecules require transmembrane proteins like channels, carriers, and pumps to pass through a cell. And if you want to transport something against the natural gradient of the system, you need energy. In RO, seawater is forced through a specialized membrane, leaving fresh water on one side and concentrated brines on the other. Water molecules can pass through the perforations in the membrane, while larger solutes can't. But RO plants can use around 15,000 kilowatt hours of power for every 1 million gallons of fresh water they produce. So what are the alternatives? What about that big burning ball of gas in the sky? Solar power could work for both seawater and brackish water. At MIT, researchers have recently developed a solar desalination model that solves some salt buildup and longevity issues and is extremely inexpensive. The sun would heat a dark material near the surface of the water, providing enough energy for the molecules to overcome intermolecular attractions and evaporate. The fresh water can then be captured on a condensing surface. Other methods like electrodialysis are both energy efficient and may be useful for extracting useful resources like copper, lithium, and cobalt from brines and wastewaters. An electric field is used to transport ions in solution through a charge-selective membrane called ion exchange membranes.